welcome. So, after some minutes of Fran having technical difficulties again, I'm terribly sorry, let's progress. In between, we're going to play Answer Smash, which some of you may have heard of, some of you may not. So, for example, we're going to see a picture of somebody who may or may not be speaking and a definition. I'm not speaking, I'm just standing at the front for a bit. I'm Francis Buontempo. If the definition is the same entity or function that behaves differently in different scenarios, we get Francis Buontempo and polymorphism, so we get Francis Bontempolimorphism. And I can use this as an excuse for mispronouncing people's names. First up, Tina.
Okay. So we probably all, by now, that sitting all day is probably not the best for us, and we should all be moving a little bit more. And although the studies on the magical 10K steps are a bit inconclusive, all the studies on walking show that walking is very, very healthy, and it's so good for your health. It limits the risk factors for a lot of diseases, actually. It seems like the health benefits plateau on like 7,000 steps a day to 10,000 steps a day, and also the faster you go, the better it is. But it actually doesn't really matter. So getting more movement in, no matter how far, no matter how fast, is always good for your health, and we should be all doing that. But how should we, as developers who sit at the desk the entire day, get these steps in? Not everyone has the time to walk around for hours every day. And also walking outside is not accessible to everyone. The weather can be an issue, or the temperature, or it might not be safe overall. And as we are developers, we know the solution to almost all time-sensitive problems is parallelism. Therefore, I bought a walking pad, which is a small treadmill that fits under the desk. This is actually a very accurate simulation of me using the walking pad. The walking pad can be put away fairly easily, so it's not too heavy, you can actually handle it. Currently, I walk or stand all day because I'm too lazy to put away the walking pad every day. But that actually helps with my steps. So on a regular working day at the home office, I get in about 20,000 steps a day. And here are some things that I learned since I've been doing this. You should start slowly. It actually needs, your brain needs to adjust to walking and typing at the same time. But after a few weeks, I got really comfortable with it, and now I just hop on and off the walking pad, and it doesn't bother me anymore. You should also wear shoes, because the walking pad has a very hard surface, and although I really like walking barefoot, and it's also healthier for you, you should wear shoes. And trust me, you should wear pants. I know people don't see you, but if there are people here, you're used to wearing skirts, you know that when your thighs rub together, you get a rash and it hurts. So even if no one sees you, you should wear some pants. I don't see my other notes, so I have to improvise. You should get a fan, because if you're walking in place and you don't have any wind coming towards you, it gets extremely hot. So a fan actually helps with that. But you can use this to advantage when it's winter. You don't have to heat the room, because it will get warm enough once you're on the walking pad. It's really helpful with today's energy prices. I don't know what I had last, so I'm going to skip to the next slide. So these are some stats that I grabbed from my Fitbit since I started using the walking pad. And the steps that you see here are actually are estimated to be about 2,500 kilometers, which is about the distance from Berlin to Iceland. So that's pretty cool. This was my best week. Not all weeks look like that, but this was my best week. This is my office day. This is the weekend. And but overall, I think I do really well. And I went from an average of like 5,000 steps a day to 15,000 steps a day. And I really feel the difference. And please note that I know that this is also very privileged because I have the money and the space to actually have a walking pad, and I'm able-bodied. So, but if you have the means, you should actually try. So it might be really good for your health. Thank you.
Answer smash? No. Andrew, Marshall, allow, something like that. Matt! The clicker, mic.
Clicker and mic and everything. All right, well, this is in which we discover how much I don't remember of these slides. So, how fast are computers? I think we've lost track these days because computers go from being extremely quick, at one level, like assembly instructions and all that stuff, all the compiler explorer nonsense. That's amazingly fast, but every now and then you sort of stare at the big old hourglass going round and wonder to yourself, what on earth is this thing doing? But let's go back to the basics. So I want to try and give you an intuition about how fast computers really are these days. So let's first of all, we're going to do it in terms of some of the things that CPUs themselves do. And I want to try and give you an intuition in terms of how humans might be able to do these things. So adding two integers together, ballpark idea, any idea how fast modern computers, like your average server quality machine? Anyone? 6 nanoseconds, I heard. Well, I'm going to take it as a 3 gigahertz Skylake machine, although they're all roughly the same. It takes roughly 1 CPU cycle. That is the delay from issuing an add instruction to getting the result out, ignoring all the pipelining, so the latency from one end to another is 1 cycle, which is 1/3 of a nanosecond, which is bonkers, right? Light travels about 1 foot in a nanosecond, so 1/3 of a foot is how far light has got by the time you've added two 64-bit integers together. And that's before you consider the fact that your computer can actually add multiple of those together at the same time, and there are multiple cores inside your computer, and there's maybe even multiple sockets inside your computer. So they're bonkers quick. But let's think about it in terms of how quick could a human being reasonably add two numbers together. I'm going to say 1 second, extremely charitably, right? You could, if you were like some real polymath, you could kind of look at a 4-digit number, another 4-digit number, and go, okay, I got it, right? 1 second. So we're going to use that as our scale, roughly speaking. 0.3 nanoseconds of computer time is 1 second of human time, and we're going to use that to see how the other things stack up. Multiplying two integers together takes 4 cycles in our computers these days, for 64-bit values anyway, which is 1.2 nanoseconds, or about 4 seconds. Now, again, this is a bit hopeful that a human could multiply two numbers together in 4 seconds, but it's, spitting distance maybe for somebody who's really, really good at this kind of stuff. Dividing, faster or slower? Way slower, I heard. Yes, good answer. So the latest version of Intel processors have spent an obscene amount of space to make this a little bit quicker, but depending on which revision of the processor you're on, this is 20 to 100 cycles, which is 7 to 33 nanoseconds, or about 1.5 minutes. Now again, the intuition follows, right? Multiplying stuff together is relatively straightforward, but as soon as you have to bust out, long division, you're into a bit more of like, well, this is going to take me a while, and a bunch of notepaper. So it kind of stacks up. And also, you might think that you don't use integer divides in your code, and you probably don't on purpose, but if you've ever used a hash map, almost every hash map that isn't tuned to within an inch of its life for performance uses a modulus operation to work out which of the actual buckets it's going to land in, and a modulus is just a divide in sort of plain clothes. What about branch misprediction? It's one of my favorite topics to talk about. It's about 16 to 20 cycles. Again, it depends on when the miss happens and all that kind of nonsense, which is 5 to 7 nanoseconds, or about 20 seconds. So if your program is not predictable, every time you hit a branch and the machine has to sort of undo its work and go back on itself. It's the equivalent of taking a short, look out the window, stare out into space break. How are we doing on time? Have I got a time somewhere? Oh, all right, memory stuff. Blast. Level 1 cache. Still takes about 4 cycles to access. That's like 4 seconds. So that's like looking up something that's on a piece of paper on your desk. Level 2 cache. 12 cycles, 4 nanoseconds, 12 seconds. Maybe that's in the filing cabinet underneath your desk, right? You've got to pull out something, find which book it's in, flip to the right page. L3, 40, that's about 40 seconds. That's maybe borrowing the book off your mate's desk because he's got the thing that's got it in, that's still. So L3 memory, we've got small number of megabytes of that on a modern CPU. Main memory. Depending on, there are so many variables at play here. 60 to 100 nanoseconds, I'm going to say here. Again, your mileage may vary. Your car may be at risk if you do not keep up. Anyway, I haven't got time for that. Which is about 3.5 minutes at the far end. So that's like getting in the lift, going down to the library, going and finding the book, getting the book out, and then going back up the lift to where you are to go and look up what piece of information you're interested in. So 3.5 minutes, that's a long time in human terms. With 15 seconds left, disk stuff. SATA disks, 2 to 6 days to read from a SATA disk. NVMe, 1 to 4 days. Spinning disks, whoever has these anymore, anywhere between 1 and 12 months. Network stuff, pinging the person next to you, a week. Google, 1.5 months. Last one, 9 years.
I think he owes us a second of our lives back, to be fair. Matthew Benson Young, I don't think that's how you pronounce that. Andrew. Was yours in a PDF or slides? Oh, there we go, nice and straightforward. Thing. Watch that. I will be.
Save the Planet use SIMD. About 4% of the world's electricity is used to run data centers. Oh, thank you. Nervous speaker. Can we do anything by using SIMD? Oops. Obviously we can. SSE2, we can do 2 sums per operation. AVX2, 4, and AVX512, we can do 8 sums in one go. Nice. But does this actually save power? Let's do an experiment. Oops. We're going to run a max element calculation over level 1, level 2 cache, about 200 to 20,000 elements. Have equivalent implementations in SSE2, AVX2, and AVX512. We're going to measure how long it takes, use open hardware monitor to track the power use, temperature, clock frequency, and see, does it really save power? Crikey. This is challenging. We're going to generate the equivalent. I knew something was going to go wrong. We're going to generate the equivalent implementations by using the DR-cubed framework. We're going to instantiate generic lambdas with SIMD wrappers, and we get very fast code. This stuff is very dense. It's doing a 32 comparison max element reduction. Bloody hell. And this is what we're trying to avoid by using the SIMD wrappers. We don't want to work with Intimbrix. So, is it quick? Yes. This is running on a Silver 414 at 2.8 gigahertz max clock speed, 3 billion operations a second, but we're actually processing 14 billion doubles per second, which is pretty good. The experiment, we're going to run STL, max element, we're going to run SSE2, AVX2, and AVX512. We're going to look at the energy used as the area under the power curve and see what happens. Oh, by the way, STL, we're going to do a third of the work because it takes up too much of the graph. Compiling using Clang. Get off, you're spoiling my punchline. Right, STL max, using the third of the workload, it goes from about 14 watts to 24 watts usage. The clock ramps up to 2.8 gigahertz, and it takes about 46 seconds for each of these things to run. Running the same thing with SSE2, but God grief. Running the same thing with SSE2. Running the same thing with SSE2, it takes 27 seconds, so it's going twice as fast. The area under the curve is the actual energy used, but it's doing 3 times the work, so it's about 6 times more efficient. What happens when we use AVX2? When we use AVX2, we go twice as fast again, and it takes 14 seconds. So, and the area under the curve is again halved again. And what happens when we use AVX512? It goes twice as fast again. So the area under the curve of these things is basically how much energy we've used. So we use about an order of magnitude less energy when we get these vectorized instructions used. So we can save the planet by using SIMD. Running this with Intel, we get some interesting results. Very interesting results. Crikey. It downclocks, and so it doesn't go twice as fast with the AVX512, it just goes marginally faster. But the clock only goes up to about 1.5 gigahertz rather than 2.8 gigahertz. But if we look, the actual power used is about 80% of the peak power used on the other instruction sets, but we still saved energy. There's no such thing as a free lunch, but in this case, we're going out, we're buying 8 burgers and only eating 1 of them. All this stuff is available on the GitHub repo. The project's called Dancing AVX512. You can play with it yourself. It compiles under pretty much everything. Thank you.
Thank you, and sorry about the rebellious clicker. I think it's all right. I think he was looking at the wrong place. Maybe we're all right. So, answer smash. So, yeah. All fine. Now, I don't know if the clicker's going to work. I think yours was on a PDF, so I need to Alt-Tab accurately and not press any buttons.
All right. All right. Hello, everyone. Before I start, I would like to share quite great news that I achieved during last year. It took me an entire year to rewrite my library from scratch, and I was able to merge it on the main line 2 weeks ago at the end of the meeting in Varna. So it was something big for me, and with that, actually, I can start talking about physical units on lightning talks with new series of lightning talks called Mismeasure for Measure. And of course, the first one has to be about the biggest, the most expensive, and the most famous mistake we did in engineering with units in our human history, right? So it is about Mars climate orbiter, right? It is the space probe, it was a space probe that was launched by NASA on December 1988. And it was really expensive. The cost of the mission were basically we paid for spacecraft development, the launching it from the launch place took a lot of money, and also then mission operations that basically lasted for some time also took a lot of money. Everything went really nice until the climate orbiter nearly approached the Mars trajectory, and this is what was planned. It was planned to actually attend the altitude of 220 kilometers over Mars surface, but what was measured and what we actually observed is that actual trajectory was much, much lower, only 57 kilometers. So there was some mistake involved in the calculations, and as a result, the space probe went out of radio contact about 20 or 49 seconds earlier than expected. Communication was never re-established with the space probe, and space probe probably either disintegrated in the Mars atmosphere or re-entered the heliocentric space after leaving the Mars orbit. So what went wrong? Actually, it turns out that the primary cause was the fact that there were 2 companies working on the same software, Lockheed Martin was using United States customary unit system to express some quantities, and SI was used by NASA. And the official specification, the official document for specifying how they should interface with each other was SI as well. So NASA was correct, and Lockheed Martin used incorrect units. Specifically, the units involved here were pounds per second that were about to express the thrust provided by the thrusters, and it was used then by NASA to update the trajectory of the software in the space probe, right? So the conversion factor between those is 445 if done correctly, and if not done, this is how the industry reacts on this problem, right? Actually, about the responsibility, Lockheed was not blamed for this. NASA said it's our fault because we didn't test the system properly, and they didn't basically found this issue during unit testing. What is actually interesting is that they knew about the problem earlier. It was noticed by at least 2 navigators that the actual position doesn't match the calculations, but as they officially say, that the concerns were dismissed because they did not follow the rules about filling out form to document their concerns. So, assuming that they could use C++20, right? And they could use physical units library in the header files as an interface, this is how such a problem can be solved with the software I'm actually writing. Right? You provide the thruster with some get varying total inputs function returning the quantity in pounds per second. And in NASA, you can provide the interface taking newtons per second. So this is how those companies interacted with each other. And if you will take value from one, provide to another software, you will find exactly that the value is scaled automatically by the library, right? Of course, having such an interface is probably not the best idea. If they have official specification, the interface should look like this one. But the result is the same. The calculation provides the same results, so this is fine and correct. So with this, I would like to invite you to actually try the software and provide some feedback about it. Thank you very much.
That was exactly on the nose. Now, can I manage to Alt-Tab, do an Alt Smash, get Richard up on stage next, and we can cope with this, can't we? Oh, I've missed out on Answer Smash. This is a disaster. Never mind. No. So, that's that one. How do we... James, did you figure out, wherever you've gone, James, did you figure out how to switch between... Alt-Tab's going to... So we've now got that one up there, but we want to close the last one. I think I need to press Control page down simultaneously, or James needs to come and help. Have a mic.
Thank you. Yep. PDF. No, sorry, PDF.
Oh, right, okay. Good stuff.
That's it. Yep. That is me.
That might work.
Thank you. No worries. Okay, seems to work. Okay, I'm not going to discuss too much why we were using singletons, but this was a bug we came across recently, and I was mainly surprised at how long it took us to spot it and figure out how to deal with it better. For anyone who hasn't seen it, this is a fairly typical pattern for creating a singleton object since about C++11. Refined the mechanics of static so that it was guaranteed if you had multiple threads all call in instance, then there was no danger of getting multiple instantiations overlapping. They would block and wait for the first one to finish creating, in this case, our manager object. Any following calls to instance on any threads would all just return the reference. So this is sometimes referred to as the Scott Myers singleton after he popularized the pattern. All works great. We can call instance wherever and whenever we like, and then use whatever member functions there are on the object. The problem we had was that when the manager object was being constructed, it was actually calling into a C library to go and get a resource that it was populating its internal member variable with, which we would then clean up during its destruction, which was all great. Apart from the problem that we were getting was occasionally when we actually got the instance, got the resource, passed it into another C function, we would then get a crash. The fact that I've simplified it here to look like a pointer, you can probably guess what's going wrong. Problem is, create resource doesn't always succeed. Problem we had was, well, this is a singleton. The singleton got created once. Whether or not the internal resource was constructed, it was checked for locally, so everyone thought everything's good. So we kept looking through the call stacks, because this was from a client site, and kept just blanking out the singleton instance access because we knew the pattern was bound to be working. Once we had realized that the pointer was going wrong, it was, okay, where can we trap it and check for it, and how could we get it to have another go? Because most times, if the create resource was recalled a second time, it would work fine, and we'd have no problems. But the static only gets tried once. How could we get the static to try more than once? So this was an example of a problem we had. If we did try calling it more than once, because the static has already been created, then on the second instance, we were still getting the same badly formed manager. It was never actually retrying the initialization. It also is unpleasant because the only way we can detect the problem is by going in and not checking the instance, but by checking the resources itself, which means we have to understand from the poorly documented interface what might go wrong. We looked at various possibilities, runtime checks on is it a valid singleton, and if not, then reinitialize it, so some sort of just-in-time thing, or getting in there in the static construction and having some sort of a loop that would keep trying it until it succeeded, but then we couldn't really risk that getting out in the wild in case it never succeeded. We had some ideas. Could we somehow have nested static objects so that the outer one wouldn't run if the inner one hadn't completed successfully? None of them really worked, but they did all lead us towards the idea of realizing or thinking more carefully about static. And the fact that static only runs once, but crucially, it only completes construction once. As soon as we started thinking about that, we realized if we interrupt the construction by throwing an exception if it had failed to create the resource, then we could have a new pattern in our instance getter that put the static instantiation inside the try, which would never complete until we'd actually got a decent resource. That did force us to then wonder, well, what are we going to do in the catch? We can't return a reference anymore, so it forced us to change the interface to a pointer. But that actually had the nice side effect of giving us a much clearer interface of when users need to check their singleton before using it. But now we're getting the desired effect that if we want to, if the client wants to, and it's up to them, then they can retry with the hope that we'll actually keep retrying until it succeeds. Once it has succeeded, they're not going to pay the penalty anymore. Takeaways from this: just because you've successfully constructed something doesn't mean it's actually usable if the internal state is not the way you were expecting it to be. It also reminded us to, run out of time. Check your assumptions. Thank you.
All right, let's see if Alt Tabs and Answer Smashes works this time. No, Fran's focused on the wrong thing. Ha, there we go. And now I need to switch back to a PDF, and Björn's up next. We did miss out a smash. I knew I had enough. I thought I had enough. So now I need you to be able to see the white thing on the white background, which I can't see with my varifocals from over here. It's fine. It might work.
All right, a splash of color. Let's start with going back in time to the year is 1994. I had recently landed my first job as a C++ developer working for Ericsson. We made huge switches. There were racks from wall to wall, from floor to ceiling, and I was called down to the lab by one of our systems testing engineers. He wanted me to have a look at something. So go to the elevator, travel down a few floors into the lab, into this enormously noisy environment, and he didn't want to show me that though. He walked me to one of those gigantic Sony Trinitron screens where he navigated the UI a little bit, and he came to one screen that he wanted to show, and he increased the contrast and he leant forward almost to the point of the eyeball touching the screen, and he said, "It's green, isn't it?" It was screaming red. So, it says raise your hand if you cannot read this. That was my first contact with color blindness. He was red-green colorblind. He was not unable to see red-green, but it was really difficult for him. I estimated that around 10% of you would have a really hard time seeing this. I did not see that many hands up, so maybe I failed. Difficulty or inability to distinguish between red and green is the most common form of color vision limitation. I've seen various numbers of how frequent it is, but it's not uncommon. You also have other problems with, for example, cataracts or just old eyes that needs more contrast to be able to distinguish information. So when you are designing user interfaces, think about this. There's absolutely nothing wrong with using colors in your user interfaces, but don't use colors as the only way to convey information. Use different shapes of icons, and maybe one is red and one is green, but don't use color as the only way, especially not red and green, because it's such a common problem. There is help available. Whocanuse.com is a site you can go to where you can fiddle with the colors, and it will tell you how well it works for a number of different visual impairments, including such things as just sun glare on a screen. Color Oracle, American spelling, has a Java program that changes the color palette of your screen so you can test your slides to see how well do they work for people who have color vision problems. Do that. I have had reason to redesign my slides a few times. Regarding red-green, by the way, it's an interesting thing. It comes from a defect on the X chromosomes. So those of you who have two of those, you have a high availability redundant system and are extremely unlikely to suffer from this. For others, yeah, if it works, it works. If not, tough luck. So with that said, if you want to optimize your UI for young women who do not need high contrast and have good red-green vision, these are the colors to use. Old fogies like me will have a hard time. And that is all I wanted to say. Please use colors, but be careful about which colors. Thank you.
Thank you. So doing Alt-Tab again, and it's going to be fine. So answer smash, and this one I've thought about. Over to you. 5 minutes max.
Okay.
Thing there. press that one.
Okay, that goes forward.
And if it all goes wrong, press the buttons or get James to help. I'll be drinking Guinness over here.
Enjoy. Hello, everyone. My name is Sandor Dargo, and after 9.5 years, I changed jobs last year. So I would like to share a couple of ideas with you. Put your CV together. It might seem obvious. Seven seconds. You have 7 seconds to convince your recruiter. They receive so many applications that they don't have more time to read your CV. So it's very important that the most important details stand out of your CV immediately. And for that, well, you have to invest the necessary time and maybe even money. I didn't pay for someone to write my CV, but I did buy a book about how to write a CV, and I spent a lot of time reading it. I can share some resources afterwards. So it's very important that you make it easy to read your CV, but still it has to tell a story, like how you became the person who you are. But at the same time, you have to keep it short. If it's longer than 2 pages, even if you have decades of experience, just cut it, because nobody will read it. Tip number 2, research your target companies. You have to know your dream. You have to know what's your dream job. You have to define the characteristics of your dream job. For example, for me, well, I wanted to work with C++. I wanted to work from home, no office. And, well, I wanted to make good money. So based on that, I did a thorough market research. I used many different sources. You cannot really just trust 1 or 2. And, well, then I knew who I should target. But you also have to think about the long term, because maybe you are not ready for your dream. Still, you might want to do the interview because you want to build a connection, especially if those are like smaller companies where people don't change so often. So doing the interview can help you to figure out what you still lack, and you can build up a plan based on that. And don't forget to ask about the re-interview process, because maybe they will tell you, okay, we like you, but you still need this and that. Please come back next year. And if they tell you that, well, document it. Your memory is volatile. You will not remember. You have to practice consistently, even if you are a senior developer, because, well, I guess we all know this meme. The technical interview and the actual job, usually they are quite different. And most senior engineers, I think, we need to practice, and don't be ashamed of that, because, well, you know, the interview and the job, they are 2 different things. You have to study the interview processes and make a plan, and then try to stick to it. Even if you like skip a few days, it doesn't matter, just go back to it. Don't say that, well, okay, I ruined it. No, continue to practice. And this is, I think, something very difficult, but very important on a human level. Don't take rejection personal, because it will happen. It's completely normal. No matter who you are, you will get rejections. Try to get feedback from the interviewer and act on it if necessary. And don't let it ruin your confidence. That's probably the most important thing that I can say. Because it's not about you. It's probably about what you offer at the moment. And, well, if it's personal, because it might happen that it's actually personal, then the sooner you know it's the better, because probably you don't want to work there if it's personal. One last thing, you need a referral. No matter what, you need a referral. I sent out quite a few applications. I think I had quite a good CV, but I rarely got responses unless I had a referral. But here's the catch. A fake referral is also a referral. It doesn't have to be real. Use your network, use LinkedIn, use other tools. Ask people to give you a referral. And, well, there are some available sites I will share. It's really useful.
The next day, I got calls almost all the time. So, put your CV together, research your targets, think about the long term, practice consistently, accept rejection, and get a referral. Thank you.
Thank you. I was chasing you. Thank you very much. One more answer smash whilst Jonathan wends his way up here. No, I'll show you later. We haven't got time. And finally, we just need this to focus on the right thing. That one. And now I've got to make the white mouse thing on the white background go over here, go this way, click. And now I need to go and drink a bit more Guinness. That might work.
Okay, so string literals have the wrong type. What's the result of this program? What does it print? 4. Because the type of string literal is an array of const char, and this includes the null terminator. It's pretty obvious when you print it, you get the letters, and then you get 0, which is really annoying. The answer for that is it's a const char, so you get the begin and end overload, and it just includes the null terminator. So never use string literals with ranges. They have the wrong type. You're going to get bit by that, just avoid that. And this is a bit unfortunate. It's especially unfortunate because at things that will work, for us, strings are just ranges. So we don't use std_string with its bazillion member functions. We just use range algorithms to find things, to search things, to do things. For example, we also don't use format. Instead, we use ranges. So we just concat our string parts together and have a range that converts an integer into a range of characters. So we just use ranges, but we can't use std begin and end because they return the wrong thing. So we have our own begin and end, and if you have an array of char type, we subtract 1 in end. But that's not really ideal. For starters, we can't really have regular arrays of char type because they will just be wrong there. And we also want to use std begin and std end and not have our own alternative hierarchy of things. So there's a fix to that, and that is to give string literals the correct type. So we can create the correct type, a string literal, contains a pointer at length, and we then have it return the correct thing and make it implicitly convertible to the C string. And then we have a user-defined literal. It takes the string, it takes the length. This does not include the null terminator. We just return the type. And note that we call it _tc in the global namespace, because if you want to use a string literal, you have to use using namespace for a user-defined literal, which is really annoying, so we just put it in the global namespace. And with that, it just works. So size is now 3, and we can print it correctly. And this is really useful because we use that sort of thing a lot. Just use _tc for the string literals. But we can be even better. So for example, we want to call a string C API that takes a C string. So we just pass it a C string. But when we want to add some prefix, which is another compile time constant, we have to use temporary allocation, get the C string. That is unfortunate. There's a fix for that. We can have the preprocessor concatenate the strings. We use that a lot in the code base because it's, what else are you supposed to do? Well, we can use our type again. So we first introduce a literal range. This is a literal range of the given t values. It will dynamically create an array when instantiated the begin and end to return that pointers, gives the correct result even though it includes a null terminator, and is also implicitly convertible for the C string. Then we change our UDL to return that thing. So since C++20, we can take a string as a non-type template parameter. So TC string template parameter just wrap it over a char array. We get our char array. We convert that into a literal range using index sequence and an immediately invoked lambda. And then now IBC_TC is TC literal range of char and ABC, which is an empty type and will create an array as needed. And then we can overload TC concat. So if you concat one or more literal ranges, we just get a new literal range. This doesn't actually instantiate any memory, it doesn't create any strings, only when we use it. When we use that, we will trigger the conversion to the C string, have a C string can pass that on to the cppia. So this is pretty convenient. Another thing we can do is, for example, so by default, all strings are ASCII. And so the type will be tc-char ASCII, which is our custom type to indicate that something is ASCII. If we want UTF-8, we use the U8 prefix, but we don't want char80 because nobody else uses that. So we just use char, right? We can do the conversion and sort of just get the correct type out of there. And on Windows, you have to use UTF-16, but you can't use char16 here, you have to use white char, so we will do that accordingly. So you can just use the U prefix and get a white char out of it, so we can just pass that onto WinMP. We also have a function that converts a range to some other character type using Unicode transcoding. And if you have a literal range of char ASCII, that's straightforward, just change the char type. You don't have to touch the data, it's just ASCII in any encoding, so we can have like zero overhead conversions from ASCII strings to any other encoding entirely happening at compile time. They will not even show up in the memory anymore because they won't be instantiated. So that's pretty convenient. We will add that to our open source library. It's not yet because the guy in charge of maintaining it is currently at a conference in England. But once that's done, it will be there. If you're interested, we are hiring. Thank you. I'm out of time.
Well done. And concentrating on Alt-Tab, I mean, how hard can it be? That one, then that one, and... that might work, that might work, that's...
Thank you. Hi, my name is Elliot, and I'm going to talk about the multiple include optimization. So back to basics. We have a very boring CPP file and a header. The preprocessor comes along and just replaces it. We all know this. If you happen to have two in your file or another transitive include, we would get two definitions. We would break the one definition rule. Whoops. So we fix this with include guards. We check if this macro has not been defined. We defined it. The rest of our body, end if. Or pragma once. So much easier than this. And then this is all fine. We can include this thousands of times, no problem. But the second and the third and the fourth time that the preprocessor encounters this, we see the if not defined, and it needs to skip ahead naively to the end if. And preprocessors are fast. They can do this between 100, 300 megabytes per second. But if you happen to include like vector, that's almost a megabyte of stuff. That's like 5 milliseconds. And if this is happening every translation unit and you have multiple includes of vector through different paths, it can add up. So there is an optimization that most compilers do, which is the multiple include optimization. So if your file is properly guarded, and this is the canonical properly guarded, or pragma once, so you're allowed comments and white space above the guard, below the guard. You start off with if and def. You can actually have the define any way you want. They don't really care. You don't even have to have it, but it has to have this if and def. And every time that the compiler or the preprocessor sees the include directive for this file, if that macro is defined, it will skip this file or use pragma once. So this goes wrong all the time. So if you have your includes outside, if you have any function definitions, declarations, this will go wrong. So just make sure everything is within. If you're trying to combine them pragma once and include guards, you don't really need to. There's one case when you do, but you probably don't need it. I've seen this happen where this use pragma once was never defined because the include happened afterwards. So we never get to this pragma once. But because we have something outside of the include guard, it disables this optimization. This will compile just fine. You can include this hundreds of times. It will just be a little bit slower. Has anyone seen a lone hash symbol? Anyone know what that is? It's the null directive, and it is guaranteed by the standard to do nothing. It does nothing. GCC, Visual Studio, will allow this. Clang won't. It will disable the optimization. If anyone wants to go through and have a look at Boost preprocessor, they have thousands of these outside the guard. I haven't seen anyone else do it. So this is now fixed in Clang, the next version, which will be 17. So you can go ahead and stick null directives outside your guards until you get bored. Visual Studio won't optimize this. Don't use if not defined, if and def. So thank you very much.
Yeah, so the history behind this talk is that last month in C++ now, JF, is JF in the room? I don't see JF. So JF asked people in the lightning talks to nominate their favorite undefined behavior. I had something in mind at that time, but I didn't have the example, so I prepared the example and here I am. So let's see. Well, some spoilers here, so sorry about that. You should not be seeing anything like here. Don't look, don't look, don't look, don't look. Don't look. Don't look. Yeah. So I think it's fair to say that everybody here loves C++. Well, I love C++, and I wonder if you, like me, you wonder if C++ loves me back. So I wrote a program to ask C++ if it loves me back. So just pay attention to the green box. And so I wrote this thing, and then I just can ask C++, what is feelings about me? It loves me back. So I'm very happy, very happy. But I need something more. So what about the static assert? That C++ is not that. C++ is kidding me. Oh, I broke his heart. So apart from the all emotional drama here, did you see what just happened? Did you see what happened? Again. A static assert changed the runtime behavior of the program. What is going on here? Any guess? Instantiate something, some undefined behavior, which one? ODR violation. So that's it. So ODR violation is my favorite undefined behavior because of the example. So to be more serious now, so you can see what is happening in this example here. So actually, and sometimes we might use these in code. So people do the straight is complete, and then they branch if the thing is complete or not. So be really careful when you do that. And that's all. Thank you very much.
Welcome to my C++ on C 2023 lightning talk entitled C++ versus Haskell versus BQN. My name is Conor Hoekstra. I go by code_report online, Twitter, YouTube, etc. This is my About Me slide. I don't have time for it. This is the 3 podcasts I have. I don't have time for it. If you're interested, go check this GitHub repo. That's where you can find all the stuff about me. Today, we are going to be solving a very simple problem in 3 different languages, and that is filtering in odds. So here we have an example list 1, 2, 3, 4, 5. If you filter out the evens in the odds, you end up with 1, 3, 5. So first, let's take a look at our first C++ solution, and we are going to use a for loop. Boo, we don't like for loops, but that's where we're going to start. We're making use of a vector, pushing back, and pretty straightforward C++ 14 function deduce return type, C++ 11 auto, C++ range-based for loop. But you should all be thinking, what algorithm should we be using? Nope. All right. Nope. All right, copy if. Do your homework, folks. Copy if here, we're basically just making use of a lambda that checks if it's odd. So this is C++ 11 lambda, except it's actually not. It's a C++ 14 generic lambda. And we can do a little bit better here because in C++20 we got the range overload. So we no longer need to specify the iterators. This is fantastic. So C++20 range overload. But we can do even better now in C++20 because we got ranges. So now we have access to a filter function. This is fantastic. C++20 ranges. And now we're going to take a look at the equivalent in Haskell, which is going to make you quite sad. We all love Haskell. And this is the equivalent Haskell code. A lot nicer. But guess what? You actually don't need a lambda. They've got a function called odd. Guess what? It can also be point free. You don't need the x's. Guess what? At this point, you don't need the function. You can just use filter odd. All right, folks. Moving on to BQN. This is where we got 3 minutes left. We're doing great. We are going to do Can you take the mic now?
Yeah.
Alt tab. We're going to live code, folks. So BQN, it's the newest APL. It's a great language. So the brace x brace is a function, the identity function here, and we've got range 5, which just gives us 1 to 4. So we're going to do a 1 plus to get that 1 to 5. So now we've got our input sequence. How are we going to filter this? First thing we need to do is build up a Boolean mask. If Tristan's in the crowd, this is the function we were talking last night. It's called compress or replicate in BQN. This gives us a Boolean mask by doing 2 modulus. Now we just need to parenthesize this and pass it the original sequence, which is going to filter out anything that corresponded to a 0. We're done. Fantastic, folks. Moving back to our slide deck, we're going to take a look at a few other solutions. So that solution we just looked at can be made point-free by doing the following. So we've got the I combinator on the right and the phi combinator. Fantastic, folks, but we can do even more. So taking a look at another explicit solution, we're making use of the W combinator here, but we can make that point-free as well by doing the following. So now we've got the phi combinator, another phi combinator, the W combinator, the I combinator, the I combinator. Am I going to explain it? Absolutely not, folks. And We've gone back to our previous solution, and these solutions aren't even the optimal solution because we can't make use of, folks, the sigma combinator. Fantastic. Gonna explain this? Absolutely not. If you're interested, check out combinatorylogic.com, BQN pad to try out, BQN or APL at tryapl.org. Thanks for listening.
Thank you. And on that note, I can now relax and finish my Guinness. So I think we've got a few spaces tomorrow, but we're going to have to keep it tight. I'm going to have to learn how this Alt-Tab thing works. So there's a couple of QR codes dotted around. If you want to submit a talk, there's only a few slots left. But if you've got some slides, it'd be cool if you could share them by about lunchtime or so. And at that point, the evening is yours. Hang around and chat if you want. 3 people might have found a card on a seat that says you're a winner. If you'd like a free e-copy of my book, then fill it in and I shall send you the details. See you tomorrow or in the bar.